So we had gotten to part E, and E is talking about the total distance. So when we're talking about distance, we're talking about position, aren't we? And so this is...
Excuse me, teachers, for this announcement. Class officers need to come to the office during advisory today. Please check in with your advisory teachers so you're not counted absent. Thank you.
Yeah, at the beginning of the year, you would have gone through that. So we're talking about the area under the curve, except for if you're talking about distance, you're not talking about this is the negative area under the curve and this is the positive, right? So when we're talking about the total distance, we have to do the absolute value. And here we found the average by dividing by 4, but this was negative 30 is how far it went, plus it went 60 above. So when you do that, you get 90 units total was the total distance it traveled.
So total distance, not the distance from the starting point.
Well, that would be your total distance.
Well, because if it's the distance from the starting point that it has traveled, it would be 30, but not.
It's traveled 90 total units. Some of them were in a negative direction, right? So that's what we're talking about. How far did it travel? That's the total distance. When is the... Yes.
That is just... How would we find that?
So here, we had already found the area under the curve right here.
Okay.
So here, you find the area under this.
Under the line?
Yeah.
That's for anything, I guess.
Because it's given us the velocity.
Okay.
And we're trying to find the position, so we're kind of going backwards, right?
Okay.
Yeah.
So,
Area.
oh, sorry, but how do we know that the area is
Yeah.
the distance? It's been a long weekend, I'm sorry.
No, it's fine. You just are going to take my word for it right now.
Yeah.
It's going to make more sense when we get into further units when we're doing integrals. Because right now, the way that you know to go backwards is to find the area under the curve.
Like
And
on
since
the-
we're starting with a velocity, we have to go backwards to position,
Okay.
right? It would be the integral, which we're going to do, or the antiderivative in further units. So to find the position, you're going to do the area under the curve. So you find the area under the, so like here, the area under this.
Okay.
And the area under this. This would be a negative area because it's negative. This would be positive.
Okay,
But
so
because we're looking for a total distance traveled, we don't care that it's negative. It was still a distance.
So like the distance at 1 would be the area of everything
Right.
from 1 to the left?
From here to here. So that would be 1 times negative 10. So that would be 20, right? 20 units. That's how far it traveled. This would be this would have traveled, this would have traveled 10 units. This would have traveled 20 units to here. To here it would have traveled whatever that is. 25 and a half, 27 and a half or whatever.
So on the average velocity, why did
Yes.
we use the V, like the S of, oh, because it's not position.
Right, and you
It's
you could have found the average by doing this minus this over this minus this, right? But then you have to divide it by however many there were. So you would have ended up doing the same thing. It would have gotten the same thing.
You had to divide by.
If you're finding the average velocity, if it was position, you would have done S of whatever, because that's the derivative, right?
Right.
Now we're talking about the derivative here. What's the slope, right? Yeah. All right. So when is the object slowing down? How do we know this? We know when the object's slowing down is when velocity and acceleration have opposite signs. Do you agree? So when v of t and a of t have opposite signs. So where does that happen? Well, here our velocity is negative, but it has a positive slope. Do you agree? So from 2 to 4, it's going to be slowing down. Do you agree with that?
Yep.
And then up here, this is positive, but this would have a negative slope. Do you agree? So also from 8 to 10, it's going to be slowing down. So this happens from on 2 is less than, t is less than 4, and I guess we need to say what happened there. So here, velocity was negative, so less than 0, and increasing. Do you agree with that? Velocity was negative and it was increasing. And on 8 is less than t, less than or equal to t probably. Just less than. Less than t is less than 10. Here the velocity was greater than 0 and decreasing.
Does it matter what less than or equal to?
At the point, it's not going to be less than, so probably shouldn't include it. All right, when is the velocity increasing?
Anytime it's above the, no, that would be anytime it's increasing. Right.
So from 2 to 6?
Yes, from 2 to 6.
The acceleration would be increasing anytime it's positive. No, the position would be increasing anytime it's positive. That's the one.
Yes. All right, so when acceleration is greater than 0, do you agree with that?
Oh,
Because that would be when the derivative is greater than 0, right? When acceleration is greater than 0, then the velocity has to be increasing. Is that fair?
wouldn't it be A of t is greater than 0?
That would be fine too.
Okay, I just didn't know.
When the
Oh, 'cause
acceleration is
A
great.
is the same. Okay,
Yeah.
never mind.
Acceleration is going to be your slope of your velocity function, right? And this happens on 2 is less than t is less than 6. It's when that slope is greater than 0. It's positive. All right, on what intervals does the object move at a constant speed?
1 to 2 and 6 to 8.
It's from 0 to 2 and 6 to 8, yes. Constant speed from 0 is less than t is less than 2, and 6 is less than t is less than 8.
And that's when A is 0.
Yeah. When a equals 0. That's right. And your acceleration is 0. Which makes sense, right? If your acceleration is 0, it's going to be moving at constant speed. It's not slowing up, not slowing down, not speeding up. All right, calculator question. So you'll need your calculator here. All right, an object moves along the x-axis for time, where time is between 0 and 6. The velocity of an object at time t is given by v of t equals. For t equals 4, is the object speeding up or slowing down? So how are we going to know that? We need to know when the velocity is and the acceleration are both the same sign, it's going to be speeding up, and when they're not the same side, it's going to be slowing down.
Should we graph this?
So we need the velocity, right? So putting it into our y equals would not be a bad thing. Do you agree? All right, so, and I need it between 0 and 6 for my x, right?
So for your window,
That's
would you,
not what I got. Wait, can you go back to your y equals?
ln of x minus x cubed plus x squared plus 2x to the 4th.
mine looks like this.
What's yours look like? Yeah. So if it's in his standard window, it would look like this, right? But we want our
Oh, maybe mine wasn't in the same window. Okay.
we want it between 0 and 6 for our x.
Wait, how did you do the raising up to the? Because I just did the caret.
Yeah, that's what I did. And then I did. You can do 4 divided by 5 in parentheses, or I just did a fraction
Okay.
up in my caret.
Okay.
Is it better?
Yep.
Okay. All right. So now that it's in there, I need a function value, don't I? So what I'm going to do, instead of plugging that in, I'm going to actually just do my vars, y vars. I want the function value at 4. So v of 4 is about 4.49. What's wrong?
Instead of hitting enter, I hit clear.
Oh.
I'm so sick of doing that. I do that all the time.
4.4969, and it just kept going. Now, to find a of 4, that's going to be the derivative of v at 4. Do you agree? Do you remember how to do that on your calculator? If we do alpha window, that gives us some options there, some function options. There's other ways to get to that, but you're looking for that in derivative. And we're going to do with respect to x, and I already have that function plugged into my y value. So I'm just going to go to vars, y vars, function. I want that function that I plugged in, and I want it specifically when it's at 4, right? And so this is negative 2.7131, and it just keeps going. So, since v of 4 is greater than 0, and a of 4 is less than 0, opposite signs, right? Means the object is what? Slowing down. At t equals 4. At what time on 0 to 6 does the particle change directions?
Whenever v of 4 equals 0.
So whenever what?
Oh wait, would that be whenever v of whatever equals 0?
V of t?
Yes.
When v of t equals 0. I agree.
That's when it changed. Yeah.
Right? Because we're talking about where it's changing position, yeah? So it's going from negative to positive. So we can find our 0 there, can't we? So I'm going back to my graph. I'm going to do second calculate. I'm going to calculate that 0. Left bound, right bound. I don't want to guess, I want to know. And it tells me that at t equals, what, 0.391, and I'm going to even put an extra 0 there. So v of t equals 0 at t equals 0 point whatever, and v of t changes from what, negative to positive? So the object changes from left to right. Would that be true?
Mm-hmm.
Yeah. So we're actually talking about the position, aren't we? Given the velocity function, yes? So thinking back to that, when the slope of our position was 0, we had a 0 at our velocity function, right?
When the slope is 0?
When the slope of the position function was 0. Is that fair? Think about a position function. When you had a position function, it would have been 0 slope, right? To get the 0 for the velocity.
Yeah, I think I know. Like it's like the
Right.
V kind of, or like.
Because just think about anything. The slope, when your slope is 0, the derivative is 0. So if the slope of the position function is 0, then the velocity is 0. Do you agree with that? Because position, velocity is your derivative, yeah? Does that make sense? Okay. So you're thinking forwards and backwards on these, right? All right.
And then there's another.
There is another one, right? So we have to do that same thing for the other one. Calculate our other 0, because there is another one in that same interval. And this time it's moving from positive to negative. Do you agree? So that whole justify means we've got to think and write a whole lot more. All right, so here at t equals what, 5.0076, v of t is 0, right? And v of t changes from positive to negative. Is that fair? So the object changes from changes direction, I guess. From right to left. Do you agree? All right. In example 5, it says a particle moves along an x-axis so that at any time t equals 0, its velocity is given in meters per second by this function. What is the acceleration of the particle at t equals 4? So we know that the derivative of velocity is acceleration. Do we agree? And it also asks us, what does this tell you about the direction of the particle? All right. So we need a of t. In order to do that, we're going to have to find the derivative at 4. Do you agree? Derivative of that function at 4? And I probably need to make sure my calculator is in radian mode, because mine is not. So to do the derivative, alpha window, derivative with respect to x of 4 plus 2.3 sine of 0.85x when time is 4. So I get a of 4, not t, but a of 4 is approximately negative 1.890. So what does this tell us about the direction?
It's going down, or it's going to the left.
At a rate of negative 1.890 meters per second squared. Yep. The particle is being pushed to the left at a rate of negative 1.890 meters per second squared. Oh, man, sorry. Example 6. An object moves along a line so that at time t is between 0 and pi, its position is given by s of t. What is the velocity of the object when its acceleration is 0? Describe the behavior of the object. Okay, so it asks for the velocity when acceleration is 0. So we're going to have to find the velocity function, but then we're going to have to find the acceleration function, set it equal to 0 to find your time, right? Does that make sense? So v of t is the derivative of s of t, and we're going to actually have to have that function, so we're going to need to actually find the derivative. So finding that derivative, we would have what? Negative, looking at this first one, negative 3 times sine, the derivative of sine is cosine of 0.25 t squared, but then we have to do the derivative of the inside, don't we? So times what? 0.25 times 2 is 0.5 t. We agree with that? So s prime of t would equal what? Half of negative 3 would be negative 1.5 t times cosine of 0.25 t squared. Is that fair? Okay, so you can actually, we could find acceleration, find the 0, or you could graph the derivative of this. Let's see. X. Okay, so to graph the derivative, right, because that's what we need. It's asking us, we need when acceleration is 0. We need the time. Do you agree with that? So we need the time when acceleration is 0. Well, acceleration is the derivative of of v of t. Yes? This is not the derivative. This is just v of t. I need the derivative of v of t to get a of t, and I need that to be 0.
Can we not just do it like here?
You could totally do that by hand again, right? You could do it. You could find acceleration and set that equal to 0. You could graph it, whatever. If you did, which we can do that here. You would have what? You'd have to do the product rule, wouldn't you?
Oh, never mind.
Yeah. I mean, you could totally do it, though. You would end up with 0.75 t squared sine of 0.25 t squared minus 1.5 cosine of 0.25 t squared. But the other way to do it is to graph it. So to graph the derivative, that's what I would do. So what I would do is graph derivative of v of t on 0 is less than or equal to t is less than or equal to pi, and then find the 0. So to do that, you go to your y equals, you do alpha window, and we're going to graph that derivative. With respect to x, we're graphing negative 1.5 cosine of 0.25 x squared. Oh, not tangent. Doggone it. There we go. And you want it where an x equals x. And so if we graph it at that point, oh, I just messed something up. Let me try that again. Negative 1.5 t, that's what I messed up. Negative 1.5 t times cosine of 0.25 t squared or x squared. But I didn't do the derivative. Goodness. Derivative of negative 1.5 x times cosine of 0.25 x squared. Close that parenthesis. This is with respect to x. And I need it over the window from 0 to pi. There we go. And so we're trying to find that 0, because that will give us our time, right?
Yep.
So second, calculate left bound, right bound. All right. So this would be when t is approximately what, 1.6165036. Agreed? So we're trying to find the velocity at that time when acceleration was 0. So the velocity at 1.6165036. And I don't have that saved in here, so I'm going to have to actually go ahead and do it. Negative 1.5 times 1.6165036 times cosine of 0.25 times 1.6165036 squared. I get approximately negative 1.92549, and it just kept going. So, the object is moving which direction? To the left at t equals 1.616 when acceleration is 0. it also asks us to describe the behavior of the object, right?
Could I also put speeding up or slowing down as that and, right? Since we know the acceleration is 0.
It's asking for the behavior of the object, so it's asking about the position of the object. And it didn't tell us whether it was seconds or whatever, did it? So at t equals 616 when acceleration is 0.
That'd be like at a rate or not?
You could have said the velocity is about negative 1.925, and we probably should have. I just kind of ran out of room. The velocity is about negative 1.925 units per time squared. When acceleration is 0. Makes sense. All right, last one. A particle moves along an x-axis so that the time t is between 0 and 15. The velocity of the particle is given by this. At what time t is the acceleration 0? What does this mean about the velocity at that instant? So here, you could do that two different ways, really. You could find the acceleration function, or we know that acceleration is the derivative of velocity, right? And we want to know when that is 0, right? We want to know the time when that is 0. So we can graph v of t. I'm actually going to graph the derivative of v of t. Math. And, yep.
When x is 0 or x is x?
X is x, because you're going to graph it and then find the 0, right?
Okay, yeah.
Oh, we need to go from 0 to 15, though. My window needs to be from 0 to 15 for x. I might have to adjust my y so that I can see it a little better. There. So I need to find my 0. So you might want to jot down your notes, right? What did we do here? Well, first thing we did was we graphed the derivative of v of t, and then find 0. So, your time is about what?
10.6.
I got 2 point something.
What? 2.15. I got. How?
Does your graph look like this?
Nope. Let's see here.
So in your y equals, did you do the derivative? Or did you just do tangent?
I did the derivative of tangent cube root of x minus 0.2x.
Did you figure it out or no?
Nope.
Let me see your y equals. So you closed the parenthesis here.
Oh.
So you just did tangent of this minus this.
That makes more sense.
So you gotta close your parenthesis here. There you go.
Thank you.
So t is approximately 2.1 whatever, right? Now, what are we wanting there? We're wanting find the time t when acceleration is 0. So this was our time, yes, when acceleration was 0. But then it wants, what does this mean about the velocity at that instant?
It's not speeding up or slowing down. Or it's not increasing or decreasing. Because acceleration is 0.
Means the velocity does not change?
Mm-hmm.
Okay.
Wait, what does that mean about the velocity? So it's increasing?
0 is not positive or negative, so the velocity wouldn't change since the acceleration isn't changing. The acceleration is the rate of change of velocity. So
When it's
if
0.
acceleration is 0, that means that velocity can't be changing.
Right? I mean, think about it. If it's not, if your acceleration is 0, your velocity is not changing at that point, at that instant.
Physics.
Okay.
But but you need to know it too. So if your acceleration is 0,
Right.
you're not going up or down, right?
No.
So the velocity is not increasing, it's not decreasing.
Okay.
The object, so that means the velocity is not changing. Yes?
Okay.
At 2 point whatever time. Okay. So the velocity at 2.1516 whatever equals acceleration at 2.1516 whatever, which is 0. Yes? Or
Is that
approximately
equals
0. Yeah. All right, at time 6, what is the velocity and acceleration of the particle? Is the particle speeding up or slowing down? Well, we have acceleration in our calculator, don't we? I could put velocity in my calculator also. So tangent of the cubed root of x minus 0.2x. So then I'd have both of them in there. So then I could do my vars, y vars, function value. So my y1 function was my acceleration. At 6, my acceleration at 6 is about negative 0.1489. And my velocity at 6, so I have that one saved in my y2. Is about 0.7095.
So it's slowing down.
Yep. Since the signs are opposite. At t equals 6, the particle is slowing down. So, what we're talking about here is if, like with the area under the curve situation, we were talking about going from a velocity function to a position function, right? So when you're going backwards, we're finding the area under the curve. Okay, when we're going forward, you're finding the derivative. Yes?
We're trying to find the, how far?
Like on this one when we were talking about position.
We're talking about like.
So you were given the velocity and you were trying to find the position, how far it went. That's when we found the distance under the curve.
Okay. And then it has a position function, that's how far the.
Position, you can see it, right?
Okay.
How far did it go? It started at 0 and it
tells
went
you,
to 6,
yeah,
right?
on your
No, what I was trying to
y-axis.
say earlier is how far from the starting point, like, if it goes from here, it goes here, and then it goes here,
Mhm.
this distance, not just the total distance traveled.
Right.
When would we be finding that? Would it say like the distance from its beginning point to the distance from 0 or something like that?
I don't know that that's going to be something that you need to focus on right now. Okay, what do we have left? We don't have much time left, do we?
Like 2 minutes.
Okay, well, then, oh,